Okay, so this is the second generator question, and part A asks us, how could you produce a larger voltage output from the generator? Describe two methods. All right, well, just to orient ourselves here, we've got a magnet that produces some amount of magnetic fields in the region of this coil, and we're kind of looking at the coil. We're not exactly edge on, but the whole thing is rotating in the direction that the blue wires, or blue arrows indicate. And that means that as we rotate this thing, we will have this being the spindle of the rotor. As we rotate this thing, we will have a changing magnetic flux, and that will create a voltage. And we want a larger voltage. Well, there's a couple of different things you could do. One would be replace the magnet with a more powerful one. In other words, increase the magnitude of the magnetic field. With more intense magnetic field, that's more field lines, that's more magnetic flux. So for the same rotation rate, you are cutting through more field lines, you're changing the number of field lines more rapidly through the coil, and that will induce more voltage according to Faraday's law. Okay, so that's one way to go about it. You could also spin the rotor faster. So if you had a more powerful mechanical input, you could probably get that thing up to a higher speed. And that means, again, going back to Faraday's law, like maybe you don't change the magnet, you just spin it faster. Well, that's going to mean that you're changing the number of magnetic field lines, so the magnetic flux through the coil more quickly. And if you do that, according to Faraday's law, you induce more voltage. So that would work. This, by the way, would also increase the frequency of the AC output. But we're just asking whether it gets larger, and it definitely gets larger if you spin the rotor faster. Okay, so those are a couple of different things you could do. You could think about, bringing the magnet a little bit closer to the rotor, right? That would effectively do the same thing as this suggestion right here, and because you bring it closer, you get a little more powerful magnetic field. So again, you induce more voltage. What else could you do? You could add more loops to the rotor coil, and that's the N here in that. That's the N there in Faraday's law, and that would work well too. All right, so a few different options for that. So for B, if the rotor went through a complete rotation 50 times per second, what would the voltage output look like? Okay, so the voltage output always looks like an AC wave, but here we're given the frequency of the wave, because we're saying in this simple thing, remember that there's this, this correspondence between a complete rotation of the rotor and one complete cycle of the electricity that is produced, okay? So what we would have in this case, here, let's do purple. Something like that. And because we're told that the frequency, right, because there's one cycle of electricity per one rotation, so if it's happening 50 times per second, so 50 cycles per second, that translates to 50 hertz. So in other words, this one cycle takes 1/50th of a second. That means that the frequency, 1 over the period, is 50 hertz. Okay. And if you label it like that, that's fine. Just with the arrow and indicating the amount of time. But you need some indication there that you understand that the link, there's a direct link between the rotation and the frequency of the AC electricity that comes out. Okay. Now for C, if you wanted this generator to deliver DC electricity, what would need to be done? Well, we only discuss at length one method for this, and it's by far the more common one in modern generators, which is to attach a rectifier to the output of this generator. You could technically use what's called a commutator brush assembly to route the power from the armature, the rotor in this case, down the rotor through the commutator onto the brushes and out to the circuit, and you get DC that way, but we really didn't go through that. So this is just rectifier. Okay. And the reason for that is that this converts AC, which is the natural output of the generator because of the rotary motion, to DC. Okay. I didn't ask you to diagram it out or anything like that, so you can just leave it at that and be done. See you next time.